Hello everyone, welcome back. In this video, I'm going to explain and provide some more context on how to manage the different data sets that's in a supervised learning data mining project. I'm going to talk about these contexts based on the CRISP-DM process model that we talked about. The content of this video is directly related to the BZAN6357 Frameworks and Methods for BZAN course, but it is also relevant to the other course, Advanced Programming course, BZAN6355. The reason is, in both courses, you will do a course project that should follow the CRISP-DM process, which deals with managing several data sets. And this point will become clear as you watch on. Now let's go. Recall that in recent weeks, we talked about overfitting in the context of predictive analytics. We talked about the cause for overfitting. We talked about how to detect overfitting, or what is the most effective mechanism or structure by which you can observe and detect overfitting, which I will show in the next slide. And we also talked about some prevention or treatment mechanisms. Prevention or treatment mechanism is only relevant to the Frameworks and Methods course. And also for that course only, we talked about hypothesis testing and the use case for that in the context of overfitting. And here is the slide that highlights the mechanism or structure by which you would be able to detect overfitting by using a train and test set mechanism, which we also refer to as twofold cross-validation. So with all that said, here what I'm going to talk about is to provide some context about managing different data sets. Although this video is primarily made for the Frameworks and Methods course, it's also related to the Advanced Programming course, because in both courses you will do projects that in which you will manage multiple data sets. And while previously, in the previous weeks, we talked about train and test sets, as in the train test split context. Here I'm also going to talk about the score set. What is a score set and how to prepare it for the purpose of the project. I'm going to put on the slideshow. Now, assuming that you have completed the first two stages of the project process, which is research or problem understanding and data understanding, then you have a data set that you are ready to do some more exploration and preparation. So we call this data, the complete data that you have for this project. Now with this data, you will enter, assuming that you have a very basic understanding of the data, where it came from, some possible issues it may have, then you are ready to enter the third phase, which is data preparation stage. And in that stage, you are also going to do more exploration, more understanding. So the second stage and the third stage are intertwined together. So with your data, the first thing you're going to do is to split it into two data sets. Split into a train and test sets. As the first step, when you start to deal with data, and some may have questions that whether or not you can do exploration directly on this entire data set that you have, or you only use one of these sets to explore the data. Now, the general suggestion is to only do exploration on a train set, because you want to keep your test set mostly untouched, except only for the purpose of confirming very high level distributions, or very high level, we call it surface problems with the data set, confirming that the structures are the same, the basic structures are the same, and that based on hypothesis testing, the overall distributions on key variables of the test set are the same as those of the train set, and that's all. You don't want to explore the test set too much. And I will talk more about the philosophy behind. So my suggestion is to do fairly deep exploration and understanding based on the train set. And then if you find any problems, developed strategies to fix those problems on the train set, you can then use the same methodology that is trained based on the train set to fix those problems on the test set. Right? So once you have split the data set into train and test, and then you do hypothesis testing to confirm similarities on the surface level between key variables of the two sets, now you are ready to do deeper level exploration and preparation using the test set. So the next phase or next stage is you do EDA, exploratory data analysis, and then you do, we call cleaning, / pre-processing, or preparation. They all refer to the same. And you only do these on the train sets. In the process of cleaning and pre-processing the train set, you found some issues such as missing values, or some other issues that we talk more in the advanced programming course, but not here. And also you identify steps that you must perform in terms of pre-processing or preparing the data set, which includes categorical variable, categorical variables, and standardization of the numeric variables. For categorical variables, you would need to perform the one-hot encoding or create dummy variables to represent the different discrete categories of these variables. And all of these are common issues or common steps included in the pre-processing stage. In this course, we de-emphasize missing values because we have so much content to talk about. But in the advanced programming course, forming a strategy to deal with missing values, which we call imputing the missing values, is another critical step. So these problems are identified or recognized by using the train test only. And since the train test and the test set share high-level similarities, including the issues and steps identified here, so using train test alone to perform these tasks would not miss critical, will not lead to critical hindsights or critical loss of information about the test set. So the philosophy is good. To find solutions to these problems or steps, we use what we call transformers. In the Python programming context, these performers are fitted using train tests only. These are fitted, which means trained, using the train set only, and then the fitted version the fitted transformers are then used to transform which means to prepare the test set. The fitting process is to turn the generic transformers, which has no specific form of coefficients, after being fitted to the train set, they have specific coefficients that are accustomed to the train set of this project, and then using those coefficients that are learned based on the training set to transform to prepare the test set using those coefficients, which means these transformers are not refitted, they are not retrained using the test set. So although the process looks similar, they are critically different, and this difference is reflected on the codes. Alright, so you probably will guess that you will do the same transform step on a third data set, which is called score. What is score data set? Score data set is any data set or cases that are unseen to the training process, that are probably in the future. Let's say customers. You have collected data about previous customers. Use data about those previous customers to train your models, and then you prepare these data sets to train your models. In the future, new customers will join and explore your products, and these would be in the score data set. You did not have opportunities to observe the outcomes or values in the score set, and now they become observable. you are going to use your best model to predict the target values of the score data set. So one critical difference between the score set and the train or test set, or the overall data set that you had, is that there is no target value here before you apply your model to these data. The target value is missing for the cases in the score set. Everything else should be the same in terms of the structure of the data set. It should have the same set of input variables as the data that you use to train and test your model. Alright, so in a way, score set is quite the same as a test set, where you will only use your fitted transformers to prepare the score set to transform the score set, with the only difference being there is no target values, or there is no column for the target values in the score set, whereas you do have the true values of the target variable in your test set because they came from the same overall data. Alright, hopefully this process, the fitting and the transforming process, different stages engaged with different data sets, are clear. Now, after you have done the data preparation and understanding stage, then you would proceed to modeling stage, where you would train different sets of models, do some fine-tuning and improving the model, and in the process you would also engage with the model evaluation stage. And hopefully you found the best model. And after that, you will engage with the last step, last phase, which is scoring, or implementation stage. And you guessed it right. In the scoring stage, you will use this data set after preparing or transforming with the fitted transformers. In that sense, the pre-processed score data set, and use that to complete the scoring process. So that is an overview of the process model and the differences, relationships between the three sets, train, test, and score sets, are highlighted. Now, of course, you do not have to rely on only train, test, split for the purpose of detecting overfitting. There is another or more generalized technique, which is cross-validation. And you can incorporate that process in here as well. And here is how. So cross-validation is not a replacement of train, test, split. In a more ideal project management process, in terms of data mining process, I would recommend that you split the overall data into train and test, and keep the test sets aside without doing too much, other than the hypothesis testing and surface cleaning or surface comparisons of the two sets. Keep it aside, and then almost all of your work, your development work, happens would happen on a training test. You should use that training test to conduct EDA, cleaning, pre-processing, and then you have a hopefully large pre-processed clean data set to work with. Alright, and at that stage, what you would do is, at this point, you have a pre-processed training set, and then you do cross-validation. So what happens is that you create, let's say, 5-fold cross-validation. You create 5 folds. Here, you create 5 folds. You identified a few models and modeling framework, and then you do the training or model fitting on the, each time on the 4 folds of the 5 folds cross-validation data sets, and then use the remaining fold to evaluate the model. And then you iterate through the 5 folds to train the model for 5 times and evaluate for 5 times. You calculate the mean of your model performance based on the 5 times, and then you evaluate the model. You train several different models, and you compare the model evaluations based on sometimes simple metrics or sometimes more sophisticated, more complex metrics, depending on the need of the project. So in this sense, cross-validation can be incorporated in a training test split structure, and the cross-validation folds are all coming from the pre-processed, cleansed training set from the overall data set. So I say this is the ideal process because this involves complexity in terms of the project process, and I don't expect you to incorporate both training test split and cross-validation into the same project for any of the courses that I'm talking about here, the Frameworks and Methods course and the Advanced Programming course. Now, in the Advanced Programming course, I showed code snippets that demonstrate how to do cross-validation. And over there, I did not include the training test split step because of the added complexity if I did in that way. But here, conceptually, I'm giving you an overview of what those processes should be incorporated into the same process. In this course, we are primarily focused on the training test split. Once you understand this process, training test split, and once you understand, and if you understand the cross-validation performances over on the other course or through other learning, then at the next level, you can seek to incorporate both processes into the same project. Now, a few final points. The 3 data sets, the train, test, and score data sets, what are their differences and similarities? I talked about that the train and the test set they come from the same grand data set. That's why they are in the same big box. But the score sets come from slightly different source. The score set is not available prior to your conducting the project. The score set represents the true future data sets for which you do not have the a priori target values, and you use your trained model, hopefully the model that is evaluated to be the best overall model. You use that model to predict the target values in the score sets. So that's one difference. The second difference is that in the data set preparation stage, the test set and the score set are somewhat similar, other than the fact that the score set doesn't have the target values a priori, whereas your test set has the target values. But in terms of the data preparations and data pre-processing, you do similar steps on the test set and the score set, but do things differently on the training set. The data preparation or pre-processing would start from the training set we call fitting. We fit those transforming objects, the preparation techniques, all on the training set, including missing values, one-hot encoding to create flag variables, variable scaling, and sometimes also involving logarithm transformation, which is not talked about here in this course, and such. You fit those various transforming objects on the training set, and afterwards you would use that fitted transformers. You use those fitted transformers to prepare and transform the test set as well as the score set. So this is the second difference. Alright, I hope that this video helps to clearly explain the difference between the three sets that you are going to deal with in the course project, as well as their purposes, their roles in the bigger picture of the data mining project process.